All right, functions and related concepts. So in Math 10, you spend a lot of time on linear functions. And we looked a little bit at quadratics. Then in Math 20, spent a lot of time on quadratics. 20 IB, we went ahead and looked at other polynomial functions. That's why this unit that we're first doing is pretty much review. As well, in 30-1, we'll look at functions like exponential functions, logarithmic functions, sinusoidal functions. Those are the three big new ones because you have looked at, in 20 IB, we did look at absolute value functions and regular 20. Reciprocal and radical functions, did that in 20. So those are all of these sort of summarize these 9. By the end of Math 30, you've learned a lot about those and done all the transformations of them. So transformations that will be our next unit, and that will help us change the shape and the location of any of those functions that we're learning. Okay, we did that with quadratics, but now we're going to do it with every function. So, as it says, you can use your calculator to help you out with all of these. Take a look at the first one. It says, when using a graphic display calculator to graph, it's important to choose an appropriate window. That's pretty much the biggest difficulty a lot of students have, is getting the right window. Here's the same function, but with two different window settings. So remember, we often show them, even though it's vertical in your calculator, we write them out to save space horizontally. So same function, different window settings. And it says, explain why the settings on the right are more appropriate for this particular function. So basically, you want the function to fill up as much of the screen as possible. Why keep it as something small where you can see more of it if you change the window settings? And this graph starts or has an end point. It doesn't go on forever. At the left here, it starts at 0, 0. So settings are the right, more appropriate as the graph takes up most of the display window. Okay, so it's just a little bit nicer. This is a fancy setup I have here with my cardboard box to help me. Okay. So as I said, we're not doing every one. What we're going to do with a few of them is record the window settings, sketch the graph in the space, label the axes with the variables, x and y intercepts, asymptotes, any other important features, write the equation of all asymptotes, if appropriate, and state domain. Okay, so we're not going to do y equals x. That's Math 10. Y equals x squared, Math 20. Y equals x cubed, even Math 20, we did that. So I'm going to leave those for you to do on your own time, be part of your homework. Square root we talked about. 1 over x, we did that. We did absolute value, so you're going to do these. We're going to look at the ones that are going to be new to us, so you at least have an idea. And really, with y equals sine x, we did spend a day looking at the functions of that. Give you a hint here to set your graphing calculator in degree mode using that window setting. So basically, negative 360 to positive 360. So here, go to y equals, clear off anything that you have, and y equals sine of x. Close the bracket, not that it makes a difference, but let's make it look nice. Okay, window settings. So window, and we're changing. Now these, negative 360 to positive 360 is in degree mode. So we're going to have to make sure our calculator is in degree mode. We'll do that in a sec. So negative 360 enter, positive 360, enter, go up by 90s, enter, then negative 1.5, positive 1.5, just up by ones. I don't change the resolution or anything else. Okay, now I'm going to go to mode and go down the third one, make sure it's in degree. Okay, if it's not, change it to decimal. Okay, and then press graph. Okay, that's a sinusoidal function. That's your basic sine graph, y equals sine of x. Okay, it's a wave function, sometimes we call it. So properties are that it's cyclical, it repeats, it does have maximums, it does have minimums. Okay, so the range is restricted, but the domain is any real number. Okay, so we're going to do a quick sketch of that. So good to have a ruler for this course for your axes. Obviously the graph doesn't have straight lines. And do your best in terms of you'll certainly get better at graphing when we get to this unit. We spend about a month on trig. Okay, so I always kind of start here, up. I kind of call them mountains and valleys. That valley looks a little bit bigger. They should be about the same size. Well, exactly the same size, but when you're drawing them, maybe it's a little bit harder. Okay, so just do your best. Try to get at least one cycle in there. So this graph will go on forever. So domain, remember those squiggly brackets. We're going to use x and y. So x and y axis. So this will be x is an element of the set of reals. And range, well, let's take a look if you're not sure. From this setting, those values, remember the markings were 1 for the y, so that minimum value is -1 and the maximum value is +1. If you weren't sure, then remember you can do maximum, so second trace, maximum or minimum. So if I do maximum, cursor to the right, enter, keep going to the right, enter, enter. Maximum is 1, okay? And the minimum is -1. So I'm going to go -1 is less than or equal to y, less than or equal to 1, y element of set of reals. Okay. So that's the sinusoidal function, domain, and range. Next one we're going to look at is exponential, okay, with a base of 2. So you get out your calculator. Let's go to your y equals and clear off sine of x. And we're going to go 2 to the exponent x. Okay. Now we're going to want to change our window setting. So go to your window and let's just start with a standard screen. So zoom, Z standard is 6, and it will graph right away. Go through zoom. Okay. Now really, to fill up more of the screen, you don't need anything below the x-axis. Okay, so you might want to now go to window and go y minimum. Let's just do -1. Okay, and you could even make your x max smaller as well, your y max bigger. but that's pretty decent now. Okay. So what did I do there? I still went from negative 10 to positive 10 up by ones, and then I changed it negative 1 to positive 10 up by ones. Okay. And then now on your calculator, it looks like that graph is actually on the x-axis. It's not. So if you think about the value, how you would ever get a value of 0 for y, you should get stumped, right? You shouldn't. How do you get a value of 0? You can't. 2 is the base. If you think, oh, 2 to the 0. Well, remember, 2 to the 0 is 1. That's this point here. 2 to, say, the negative 4. Well, 2 to the negative 4 is the same as 1 over 2 to the 4th. So that's 1 over 16. So it's still positive, right? So as this number gets more negative in fraction form, that exponent on the denominator gets bigger. So it gets closer to 0 but never touches. So that's an asymptote. And often we use a dotted line for that. So I tend to use a green dotted line here. Okay. And so I'm just going to graph it on the x-axis. I don't know why it's so slow, but yeah, so that is an exponential function. It's going to look similar no matter what the base is. If the base was a fraction, we'll get into that. It's actually going to be opening the other way, but that's pretty much what it looks like. Okay. And we have to be patient in this method as well. There we go. Okay. So equation of the asymptote, that x-axis. Remember, the x-axis has an equation of y equals 0. Okay. Horizontal lines. Domain for this, notice the arrows are going left, down and to the left, up and to the right. So left and right means all real numbers. Okay, and the range is going to get really close to that x-axis but never touch, and everything above it. So in this case, it's y greater than 0. No equal sign. Okay, and so that's an exponential. Logarithmic functions we haven't learned as a class. You may have investigated on your own. And so let's take a look at what that will look like. So go back, clear off what you had, and now we're going to use just log of x. So there's a key here next to the 7, which is log of x. So this key, this log key that's by the 7, means it's base 10. And so again, we'll learn more. This may not mean anything to you if you haven't heard about it before or investigated it. Let's go back to Zoom Standard. It's a new graph. And take a look at it. It kind of almost looks like, right now, looks like a radical. But what's interesting is that it's actually graphed approaching this line. But the calculator doesn't like doing that very much because it's almost like it's not a function. So let's just fix the window setting a little bit because we don't care about negative x's. So let's just start at negative 1. And you don't have to go very high for y's. So let's just go maybe to 5 for y max. Or even, yeah, and then let's go up and just go negative 5 for y min. So we're changing our window settings, seeing if we can fill it up the screen a little bit better. So now press graph. So even still, if I go trace here, okay, and cursor, oops. So what happens when it gets down here, because it looks like it stops. And this is where your calculators are smart, but you are smarter, right? So you have to know some things. You can't just rely always on your calculator. So it still gives me a value there. But if I go to the left of that, it's going to x equals 0, and there's nothing given there. Because there's no point on the graph when x equals 0. So log of x is not defined when x equals 0. And basically what the logarithmic function is, it's an inverse of an exponential. So exponential, we had an asymptote on the x-axis. Now our asymptote's on the y-axis. Okay, so again, we're going to learn more, but it's a good idea to know what it's going to look like. So we will, not that one. Well, actually, I need that, so I'll leave that. Let's go here. So this, and I was going to draw a couple because it's still not really my friend. Okay, so about there. And so this is going to basically look something like that. Okay, and then this will be my asymptote. Oh, not that one. That's weird. Okay. Okay, we're going to delete that. Delete. Okay. Okay, so the asymptote's going to be on the y-axis. So, y-axis asymptote, the equation of that is x equals 0. In a minute. So you can fill that in. X equals 0. And so now the domain is everything greater than x. So if you think back to learning about inverses, that makes sense. The domain of the original is the range of the inverse. The range of the original is the domain of the inverse. So now the range is all real numbers. Okay. So those are 3 new ones that you're going to learn about this semester. Turn over the page. Again, more review about functions. I'm going to classify them, so see if you can do a little, it's more like a matching game. Back to when you were a kid, but now you're matching functions that you've learned. Go to the next. It says, write the equation of each of the 27 functions in the same box as the basic function that shares similar characteristics. There will be a total of 3 equations in each group. Once you have grouped the functions, determine the common characteristics. So again, we're not doing all of this. You could go and look at the list on the bottom right and then write each down as you go. We're going to do it a little bit differently. We're going to look at the second set of three and find the functions that match up rather than the other way around. So you're going to do these ones on your own. Okay. We're going to look at the radical, rational, and absolute value because you've seen those before, so a little bit of review. So you're going to go take a look at these and look for functions that you think are in the family of a radical function, in the family of rational, family of absolute value. I mean, some of them are pretty obvious. If you see a radical sign or an absolute value, you know to copy that out into the chart. Okay, so I'll give you a minute or two. So we're just doing the radical, rational, and absolute value. Okay, so I went through and just found those. So in terms of characteristics, I tend to look at it just the shape of the graph. Okay, try to get some details. So these are all radical functions. Remember, square root of x, that's really a half a parabola on its side. So that's, to me, is like a description of the shape of it. So I'm going to remind myself that these are all half parabolas on their sides. Is that mathematical wording? Not particularly. Mathematically, you might call it a half a horizontal parabola. Okay, but I'm just talking about how to describe it so we know. So on its side. Now, if the coefficient in front of the x is positive, it's going to be that half parabola going upwards, up and to the right. So the first two, this one here would be going down half a parabola. So the thing with these radical functions is that both the domain and range are limited, so they're not all real numbers for both of them. And I like to think about it, it has an endpoint. So the end point is the vertex. End point is the, we still use the word vertex of the, and now I'll use the word horizontal parabola because that's actually faster to write. Okay, one endpoint is the vertex of the horizontal parabola, and the other goes to infinity. So that says end point, abbreviated, is the vertex of the horizontal, abbreviated, parabola. Okay, next one. So end point is the vertex of the horizontal parabola. Next one is the rational function. These ones have asymptotes. Okay, so have horizontal and vertical asymptotes. I'm not going to go into too much more detail. They kind of have two arms, right? If they're linear, so if the denominator is just x, not x squared, then you've got your two arms and they've been transformed. And then the third one that we're doing is the absolute value. Remember, if it's linear in there for absolute value, it ends up being V-shaped. So it's almost like a parabola and it has a vertex, but it's not curved. So I end up saying V shaped. So that means domain all real numbers, range will be limited. If it's positive in front of the absolute value, it'll open up. If it's negative, it'll open down. Okay, so those are just some of the properties. Okay, so you're going to do on your own time these ones. Okay, again, we've talked about these ones on the first page, right? So you'll know a little bit more now. Those were the functions. Okay, now we're getting into review some function notation. So take a look at this funny looking function. Doesn't have an equation. I don't know what the equation is. Probably we would use a piecewise function of some kind to do it. There isn't something common that will give that. So domain and range, always look. Is there an arrow here? Nope. Is there an arrow here? Nope. Okay, so you've got to have, you're going to have a smallest and the largest value for x. Horizontally, turn your page if you need to, or look for the lowest value for y. So these all three have the lowest value, and this point has the highest value for y. So in our, what we call set builder notation, so our domain, let me just make this a little thinner, squiggly brackets, x, and I like to look at what's the smallest value of x, what's the biggest, and write those numbers down in order with space in between. So -5, smallest, 6 is the biggest. So -5, 6, space in between, then I put x in between that, because if nothing's shown there, that's the default variable, x, and then always opening to the right. Then x element of set of reals. Okay. Range, again, lowest was -2, highest is +3. So -2, 3, space in between, y, and they always, if you put them in order from smallest to largest, your inequalities always open to the right. Okay. Okay, so we're going to use the graph and our function notation to answer these questions. So let's do this, let's go by column. So the first column. I'm actually going to just change the view here a little bit. Let's see what happens there. See a little bit more. So f of -2, that means when x is -2, what's y? So x is -2, what's y? I go up to that point, and it's +2. When x is 0, what's y? So when x is 0, go to the point on the graph, y is -2. When x is 5, what's y? Go up. It says approximate, because I don't, it looks a little bit above 2. I'd say maybe 2.2. Can't tell exactly. And when x is -6, what's y? Well, it doesn't exist. There is no point on that graph. So I'm just going to put D and E. We often use that, especially when we get to calculus, for does not exist. Okay, let's work backwards now. Now we're told what f of x is. So that's like y is 3, what's x? So when y is 3, there's a point there, x is 4. So f of 4 would be 3. When f is 3, x is 4. When f is 0, what's x? So when f is 0, that's the y value, there's lots of points. There's this one, this one, this one, this one, this one. So it looks like -3. Going to approximate there, maybe -1.4. Looks like 2 and 6. oh no, 2 and 3.4 maybe, and 6. When x is negative 2, looks like 3 places, so that's negative, sorry, when y is negative 2, what's x? Negative 5, 0, 3. And when f is 4, well, there are no points, so x does not exist. Okay, it's 1:44. I just noticed that. We have to head downstairs. Okay, so we didn't really even get very far at all. Okay. Wanted to get a little further. Anyway, so let's go down, come back, let's plan to come back on, not leave right away. Maybe we'll get 5 minutes so we can do a little bit more. All right, so last column of this, think about what this is saying. So if f of 4x equals 3, what's x? So f is like y, so we're still thinking when y is 3, so when you look for where y is 3, you get this point. On the graph, x is 4, okay, but there's a 4 already in there. So basically, what f of 4 is 3. So that means in here, so f of 4 equals 3. So if in the brackets we have 4x, what must x be to get 4? 4 times 1 is 4. So x is 1. Okay? So you're kind of working backwards from that. So same thing here now. In the brackets we have x plus 2. We still have f has to equal 3. So again, f of 4 equals 3. So what plus 2 gives you 4? 2. We're going back to elementary school, right? So 2 plus 2 is 4. So x is 2. Okay. Same thing here. So remember f of 4 is 3. So 1/4 of x has to give us 4. So what must x be? 16. Exactly. So you're kind of doing the opposite. This says divide by 4, 1/4, but you're multiplying by 4 to get 16. This says add 2 to get 4, so you're really subtracting 2 from 4 to get the x value. Here, f of negative x has to equal 3, so remember f of 4 has to give you 3. So what must x be to get 4 in there? Well, it's got to be the opposite sign, right? So x would have to be negative 4. Okay, and that is helping, we're doing these questions now, so when we get to transformations, it makes it a lot easier for you. Okay, so make sure you've got those. And now function notation. You did some of this last year, so we're not going to do all of this together. Let's take a look. So you're going to do this one on your own, this one on your own. Let's look at C. So f of negative 2x, that means everywhere there's an x in the original, we put negative 2 in, negative 2x in. So f of negative 2x if you're having a hard time remembering what to do, start by just putting brackets where all the x's were. Okay? Then maybe you could even change to red. So we're replacing x with negative 2x. Okay? Then that's your polynomial work from math 10. So negative 2x in brackets squared is positive 4x squared. If you gave me negative 4x squared, that gives me gray hair. So please do not. Okay? When you square a negative, you get positive. Then negative 3 times negative 2x is positive 6x. And nothing to do with the 2. There's no like terms. You leave it as is. Okay? This, again, you can do this one on your own, this one on your own. F of x minus 5, that means you take whatever f of x is, So x squared minus 3x plus 2, and then you subtract 5 from it. It's almost like you could put brackets around that f of x if you wanted to. And then collecting like terms there, the only thing that you can collect are the constant terms. Okay, so f of x, nothing changes, you subtract 5 from it. And then let's skip to I, because it has everything in there. So I, negative 3 f of x plus 4 minus 5. It's almost like order of operations. You do brackets first. Well, there's nothing to do in the brackets, but that bracket is with f. So I'm going to copy out negative 3. I'm actually going to use big brackets because I know I have a lot of x's in f. And then minus 5. And so everywhere there's an x, I have to replace with x plus 4. So that's going to be x plus 4 squared minus 3 times, in brackets, x plus 4 plus 2. Okay. Now, if you wanted to do f of x plus 4 separately, then multiply by negative 3, then subtract 5, that's fine. But you're in 30 level math. You should be able to show nice work all in one step. Now, order of operations. Got to square that binomial. You can expand out. Again, don't give me gray hairs. Expanding that out is x squared plus 8x plus 16. If you forget the 8x, you ever watch American's Got Talent? 8x. Okay, forget the 8x. Okay, I'll just finish this up. You can check it, and then what I want you to do, what I said for you to do, then I would like you to finish this left side up to question 6. So everything up to question 6 is your homework. We'll start at 7 on Monday.